That's your warning, otherwise you're going right back to your brain.
1 plus 1 is 2.
0, 1, 1, 2, 3. 0 plus 4, no, 3. 0. 1 plus 0, 1, 1 plus 1 is 2.
Oh my goodness, it's not. Look, 1 plus 0 is 1. Okay?
It's 0, 1, 1, 2, 3.
Okay? Then you got 1 plus 1 is 2.
Exactly. 1 plus 2 is not 4. Look, look. 2 plus 2 is 4. No, 2 plus 2 is not 4. It's not 3. No.
Like how the numbers go from one to the next. I'll give you a hint for those of you still struggling.
I'm not struggling.
Griffin, do you have the next turn? Do you have the next turn?
Plus 0.
No.
Plus 0.
Oh.
Not 11. Not 12.
13.
Johnny with 13 is right, but now you need to figure out what the next term is. It is 13.
Wait, why?
Because 5 plus 8 is 13, so you go 8 plus 13. Yeah.
Hold on, so Johnny is saying the next one's 21.
Because 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13.
Wait, so then. I got it.
You're just adding those two numbers every time.
Oh, I got it.
Haley. Haley.
That is 3.
Haley. If 1 plus 1 is 2. 1 plus 2 is 3.
Yeah.
2 plus 3 is 5.
You use that number to.
And then it's 55.
Do you guys see what's going on?
Yeah. And then it's 89.
2 plus 1 is 3.
Okay. Now, here's the hard part. You see it?
I don't get it. What do you do?
Okay. Well, we're going to try and ask people, if anyone has a way, hold on. If anybody has a way of explaining the pattern without using any numbers. Explaining the pattern without using any numbers. Okay, Jay, try it out.
The one that you are trying to figure out, the next one, is the previous two. Adding.
To find the next term,
Add the 2 plus.
Oh.
now, I know we use 2, but I guess that's kind of the best way to say it. They're not using the numbers up there. They're just explaining the 2 previous. Alan. Do you guys agree?
Yes.
Okay, so let's double check it real fast. Alright, China, go ahead and move on back. Thanks for explaining that. You did a great job. Okay, so then, let's go ahead and use it. To find a term, we add the 2 previous. So is 2 1 plus 1? Check it.
Yes.
Is 3 1 plus 2? Is 5 2 plus 3? Is 8 5 plus 3? 13 5 plus 8?
Yes.
21
Yes.
8 plus 13. So every time to find a term, you have to add the 2 before it.
So it's correct, right?
Does that make sense? Now, here's the craziness. And our book expects you guys to be able to do the following. I didn't write it up there because I think it's a little bit too hard. Even kids in pre-calculus have a hard time with what the next question would have been. Let me show you what the next question is. Let's see how amazing you guys are. This one's hard. You guys have done a great job, though. This is a hard sequence. He's tricky, right? What if I was to ask for what would be, or what is a recursive? Oh, don't worry. We'll do it together if we can't do it separately. Formula
Just plug it in.
for this sequence.
What we've been doing for the past 3 days, Jay.
No, not 3, just yesterday. Recursive formula. Now wait. I don't want anyone to say anything yet. Be thinking. Can I at least go review or remind you guys what we saw at the very end of yesterday? Now you don't have to copy this yet. We'll come back to it. Hold on.
Didn't we already copy that down in our notes?
Guys, hold on. No one copy this down right now. We're just looking at it. These are recursive sequences for arithmetic and geometric. Do you guys remember what each of the pieces stood for? Who is this guy?
Radius. Or, sorry.
Yes.
Oh, because I thought she was going to
Good,
say
that's
like
the
a R.
nth term. That's the nth term. What is this guy's name? This whole guy? Sometimes it's the first. The previous term.
Okay.
The previous term.
We
And
got
then for arithmetic, this one is the common difference right here, right? This one's the common ratio. But the one we're looking at, it's not arithmetic, right? Okay, so to find the nth term, which is what Jay said is like to find your current term, we need to add the previous term. Oh wait, but we're not adding a common difference for this one, right? Huh. What are we adding for our pattern? What does the English say?
The next term.
Yeah. So to find the current term, we'll say the nth term, we need to add the two previous terms. So that's the previous. How do we get the previous?
2a.
Plus not
A
2a.
n minus 2.
We say we need to go two places back.
Okay.
We need to go two places back. This is the math
noise.
that means the same thing as the English. But to be honest, kiddos, once again, this is something that like juniors and seniors in high school, the kids in pre-cal, and even maybe cal, would have a hard time doing. So I'm not going to test you on, listen. So I'm not going to test you on needing to make a formula like this that is not arithmetic and not geometric. But some of you might be like, well, why did you even show us this? Well, I'll get back to this a little bit later on today, okay? He's actually a really special sequence. If you know who he is, don't say anything. Don't ruin it. But he's a really special sequence that has a lot of meaning. And we might be able to, if we can really focus today, we might be able to see someone explain exactly what it is and how it works. Now, before we get back to our notes, let's go ahead and grab out our homework. Let's check our answers. This was really hard. You guys did a great job.
No,
Let's check our homework out.
What was the homework?
Can I?
Yeah.
Can I turn the fractions with?
No.
Remember, you have to turn it in, not in class. You can turn it right after. You just have to give it straight to me. Is that cool, Keith? Okay. All right. Here we go. Number 2. Did you guys figure out 6n minus 2 was the odd man out?
Yeah.
He looked
Yeah.
way differently than all the rest, right?
Yeah.
Okay.
This is page 344, right?
Number 3, geometric. Number 4, arithmetic. Number 5, arithmetic. Number 6, geometric. All you had to say was on 3 through 5, whether arithmetic or geometric. And let me scroll on down. Josh, what's your question, man?
Sorry, I just want to make sure I did like the right numbers. What was the homework?
The homework was, is it not up there? Hold on, I have it right here.
3, 4, 2, 5, 11, 13.
Oh, so I did a lot more.
Too much more? Okay.
Yeah,
Then you'll
I
definitely
did-
have 100.
I did 3 through 20.
Oh, you did Coach Trapp's original one. I changed it yesterday morning. Make sure that you just check it after school because I update it during the day sometimes.
Okay. Man.
Hold on, coming back. Sorry, I am not in the right place. There we go. Can I scroll down to 7? What do we got? 7 through 9, right? 7. If you want to find the next few terms, you would have started at 0. Then the pattern was plus 2, plus 2, plus 2, plus 2, plus 2.
Wasn't it 79?
Yeah. Here's 7.
And then it goes.
So it starts at 0, goes up 2, up 2, up 2 in the graph.
Yes, I got it right. Finally.
Number 8 starts at 10 and goes down 5, down 5, down 5, down 5, down 5. And you can see the graph. sometimes it's hard to fit it all in the graph. Give me 1 second, Alan. Hold on. Alan, what's up, bud?
Do we have to write like, what's it called, you know, the whole,
A sub 1 and A sub 2.
the whole like formula? Cause I stopped.
You
after
could.
Cause then like it's kind of self.
If you see the pattern, you can just keep jumping the pattern. You don't have to keep writing all the long work. And actually, we saw yesterday, you don't even have to write the long work if you can see the pattern from the beginning. So yeah, no, that's totally fine. Finding the pattern is a great idea. Rob, go ahead. Yeah. Just for a second, okay? Josh, what's your question, by the way?
So I was asking one number for this, I didn't want to interrupt.
It's
Can you do that
geometric.
anymore?
Oh, up anymore? Yes, okay. You see it, bud?
Yes, I do, thank you.
Number 8, we already saw. Let's go down to number 9. The pattern for number 9 was, what was the pattern? Times 3. Start at 2 and times 3 times 3 times 3. Number 11, you guys can see, start at 80. And then multiply by negative 1/2 by negative 1/2 by negative 1/2 by negative 1/2 by negative 1/2. And this is one of those weird ones where it bounces up and down because it's positive and negative. Then we just have 13 through 15, right guys? Yeah. All right. If you see him, he's kind of like way down at the bottom somewhere. That's not where I want to move. Oh, I'm proud of myself. You get it?
Yeah, do everything right.
Alright, doesn't let me move it up anymore. Number 13 is start at 7
Let's go, bro.
and add 9. We have to put it in a nice formula form, but start at 7, add 9. Number 14 is start at 8, multiply by 3. And number 15 is start at 243 and multiply by. You got it, Kim. Alright, now guys, I think 13 through 15 kind of got hard, right? A little bit?
Yes, but I got it, but I don't know.
15 was a little bit harder. So we're going to look at a couple more examples like the 13 through 15. We're going to look at a couple more examples like the 13 through 15. And then we're going to learn one more idea. But first of all, okay? First of all, I need you guys to realize that I changed homework once again. Now wait, don't worry. It's the beginning of class.
Problem. It's
Okay.
like 3 problems.
Just a few of you guys wrote down this homework over on the sideboard. And to be honest, I just made it easier. Okay? I made it
That's the
easier.
actual homework.
This is the better, easier homework. Good. Anyone with really nice handwriting that can go change the numbers on the board?
I don't
Jake.
like you.
No?
Hey, no.
Actually, do it if I'm doing slow.
The rest of you guys, you can take a picture of it now so we don't have to worry about it later. And Molly can write it on the sideboard.
Oh my God, bro. What the heck is that?
But otherwise, get your homework ready to turn in.
I'm ready.
Get your homework ready to turn in. Make sure your heading is on it and start passing it back.
Wait.
Oh, did we have some
Your
questions?
hand got in the way.
Sorry.
Thank you, bro. I was talking to you, Molly.
Oh, okay.
I was talking to Josh.
Mr. X.
Yeah, I need some 15.
Oh, you see 15? I'll get it back. Let's wait to turn in homework for a couple seconds, guys. Let's wait for a couple seconds. Some people need me to go back to the answers. And someone has a question on, which one? 17? No.
Since I did some of the problems on the homework.
Watch your phone.
I don't have my phone. So I'm saying like I did some. Since I did 2 through 20, I already did some of the problems on
Yeah,
the
I
homework
understand.
tonight. So do you think I should just copy it right off of this?
Oh, and give me that tomorrow.
Yeah.
Okay. Can you hand it to me real quick? And I'm gonna write a little note so when you turn it in tomorrow, it's not ready.
Okay. Fine.
Yo, ugly guy.
Alright, is anybody still writing this down? Alright. There you go, Josh.
Oh, I'm still writing it down.
Let's get it started.
That's perfect, kid. Thank you.
I got it. No, it's the first page of the chat.
1 second.
Wait, no.
Okay, who needed to see number 15? Oh, Josh is on the sideboard then.
You didn't talk about
Alright, Jay, you still?
I
Jay?
already
And Diego's still. Alright, go ahead and start turning in homework, guys. I'll take it. Homework. Yeah, turn it in.
Turn it in, boy.
My cum card? No.
Alright, any more homework? Class homework, guys.
Oh, jeez.
What's up?
Today we need to talk after class, kid. That test. Quiz. But I'm glad you're here today. Alright. Any more homework?
I don't think so.
I don't think
Okay,
so.
you're able to find those online.
I don't think so.
What's the date?
Today is the 9th.
February. That's the first page of the chapter.
Alright, kiddos, we're gonna go ahead and go back to our notes. Back to our notes. If anybody does have corrections done today for the chapter 5 test, remember you get full credit as long as you don't give it to me now. You wait until after class is over, you come on up and you hand it to me. Or you can hand it to me after school today or tomorrow during lunch or after school. Sound good? Alright, so don't forget about that. If you have questions, come on in.
Do we have to do like all? I have 3 questions. Do I have to do all of them? For the
What?
for the test corrections.
But then you can't get bonus on those two. So you may as well wait because we do all of them.
The
No, I'm not.
the test corrections, right?
First page of
So
the
if you help me, I won't get any bonus. I don't know if I have 3 questions.
It just came out this way.
I don't.
It's been out for like 2 weeks.
Alright, kiddos, here we go with the notes. Thank you for waiting. We had to wait for a couple people to get caught up. Here we go. Yesterday, some of you did not get to write down these formulas. So go ahead and write them down now in your notes if you did not get to yesterday. Here we go. You guys didn't get these? You didn't get them. Let's write them on down, alright? We're still in section 6-7. We're continuing on right past the warm-up. Did you get them yesterday?
Yeah.
Because of the phone.
Those?
That
I already
phone?
have mine. I just wait till
Oh, and
Go
you're
get
writing these?
Pop. Pop. Come and take it.
Alright. Is anybody still writing these? It was at the very end.
Who's
Some
that
people
going
did it
to
yesterday,
get?
so you'll find it in chat.
I know. I might not be.
Let me see if
I
I.
guess. And I have to.
Let's go ahead and write down the notes. Some of you didn't get it yesterday. Yeah, 6.7. You guys will remember, if there's no number at the top, we're still in the same section. Every time. No number at the top, same section. Alright, if you guys have it, please. If you guys have it, please let those that don't have it be able to focus and get it down, okay? You're telling me distraction, you're giving more power to his distraction. You gotta ignore him. I'm just saying you don't need to, but Jack is great that you just. Because that lets you kind of keep them separate by homework assignments. Caleb.
I don't leave the earrings.
Yeah, the one he's not supposed to have is. No.
Oh. No, it's on his left ear too.
Only girls.
That's the right ear.
No.
left ear,
Right ear.
right ear.
Yeah.
Hey.
That's on the court, son.
So I remember too.
Guys, let's go ahead and quiet down. Remember, guys, and you might not remember this, but rules aren't always because we think something is wrong. It's because we're trying to be a school that can help kids from all kinds of different backgrounds. And some of you guys come from families where it's like it's not a big deal. Some of you guys come from families where it is a big deal. So we try to make rules sometimes so that we can all get along, okay? So here we go. We are in our notes. Jay, you ready to go? Okay, we have arithmetic. We have arithmetic and geometric special recursive formulas. Now, I saw that quite a few of you guys got a little lost in homework last night, 13 through 15. So we're going to gonna do another example like that and make sure that we understand who all these people are. People, what?
Gotcha.
Who each of these pieces represents. So first of all, real quick, and we've reviewed it already today. What does A sub n represent? Nth term, which could be the first term, right? Well, maybe not. But it could be the second term, or the third, or the fourth, or the fifth. It just represents a particular term. Now, what does A sub n minus 1 represent? Jay, why don't you go ahead and move on back, all right? I think I got distracting them a little bit too much. That's okay. So, A sub n is the nth term. A sub n minus 1 is which term? Do you remember? Previous. Good. I almost had it out. Previous term. Rob, remember I told you a warning? Come on back and sit right there. Bring all your stuff.
21 minutes.
Okay, and we have one last piece. Actually, two last pieces. Do you remember for arithmetic what the D?
Yeah.
What the D stands for?
The D.
The common difference.
Ooh, difference. D. D stands for difference.
Anybody know what R stands for? Johnny, what's R stand for? Do you remember?
I thought it was D for.
Ratio. Yeah. There we go. Common ratio.
Good job, John.
Hey. Sometimes we help each other out, right?
No, it was
Okay. So let's go ahead and focus back on it. Let's keep the extra comments to ourselves. So, we figured out all these pieces. Let's go do another example that we didn't get to do yesterday. Okay? We already did the other example. No worries. We're doing one more. So, we did an example yesterday where we wrote a recursive formula for what was given. So let's go ahead and do one more. Alright? Now we have another sequence, and our sequence is 1.3, 2.6, 3.9, 5.2, 6.5. Kaylee's already saying, you know what, I see addition. Do you see repeated addition, Kaylee? Yeah, I do too.
Yes, it's plus 1 point.
You guys agree? 1.3 plus 1.3. Do I have a common difference? Yes. Which means we didn't finish, I don't think. We solved that one, but we didn't solve the other one.
Oh, honey.
Oh, yes, we did. Which means this is arithmetic also, right, guys? Alan, you need to quiet down. Josh, you too. It's arithmetic. Now, what would the English be as to the pattern? Okay, we're going to the math, but what's the English? The nth term is the previous. Does that make sense? To get a term, Johnny, gotta be taken word for word, right? Nth term is the previous plus 1.3.
Did you do that the same with arithmetic?
Nth term is the previous plus 1.3, right? Now you take that English and put it into math. And that's what we've been working a lot on yesterday and today. Who is the nth term in math notation? Yeah, Jordan, go ahead. Just piece by piece. Who's the nth term? Exactly, this is notation. Good. The nth term is A sub n equals. That's the previous. Got it. So numbers 13 through 15, you guys were supposed to find the pattern and then try to take the English of what you saw the pattern to be. To get a term, you take the previous and you add, or you subtract, or you multiply, divide, and you put that pattern into math terms. Okay, so that's how we find, what were these directions again? Right, a recursive rule, or that's how you find a recursive formula. Now, we're going to be finding more recursive formulas today, but we're actually not going to be given the same information. We'll be given something a little bit different. So hang in there, we can answer a question for Jordan. Go ahead. No, recursive can be used for all sorts of sequences. It's used when we want to find just a few terms, not like the 10th or the 100th, because it would take forever. You use explicit. Yeah. explicit to go to the 100th or the 200th term, but we use recursive to get the second or the third or the 10th, something similar. Well, with recursive, it's easy to jumpity jump to like the next one or the next two or the next three. But if we wanted to jump like to the 100th term, we really want to jump 99 times to get there.
No.
So we want a different formula where we don't have to do all those different jumps.
On the test or quiz, it'll say like to get to like the fifth.
You can use almost always just find the pattern and do that recursive like just repeat it.
Yeah, and so, but will you ever tell us that we need to use like the first one?
Not need to use, but you might need to find the recursive. Aiden, what's your question? Do you go quick? Okay. All right, whoa, word for word, new notes, let's go.
Whoa! New notes.
This is the new concept for today, only one, the new concept for today. We were on that slide for a long time, Diego, so if you have any more information you need, ask me right after class. So, new information, Johnny, word for word. Word for word. Translating. Now, usually we're used to translating in the sense of like going from one language to another. Or even in math. Do you guys remember how you would take graphs and you would translate them? You would move them?
Yes.
Right? Okay. This one, translating instead, is going from one form to another. So not one language to another, but one form to another. And more specifically, one type of formula to another type of formula. Now the nice thing is, your book had all sorts of translating type problems, and I narrowed down to this one type. Going from explicit to recursive. Let me show you an example on the next page. It'll make more sense. You don't actually have to memorize explicit formulas, but I do want you to be able to use them. So, steps. If you're writing, you would get in trouble. You do you. You do you. Don't worry about anyone else. Same with you. Okay, you have 3 steps. Find the first terms. Now, I'm going to give you a couple hints. The first terms mean when n equals 1. That equals is not with an equals. I apologize.
It's okay.
When n equals 1, n equals 2, n equals 3. I think usually, can't you guys kind of see a pattern in the first 3 or so,
Yeah.
right? You usually find the pattern in the first 3 or so. But maybe, but just maybe, we might have to keep on going to a couple more. Long story short, find the first few terms because we want to find a pattern. Is it arithmetic? Or is it well, guys, there is no yes because I haven't written a pattern.
I thought you were talking about 1 plus.
Is it arithmetic or is it geometric? Right? We're going to ask ourselves that question.
Or neither.
Or neither. And then we're going to plug into a recursive formula with the a sub n, the a sub n minus 1. Couple more seconds because I'm going to change the page to examples. Okay, I want to go to examples, but we have to get there. Jazz, you get the notes okay, kiddo? Alright, so let's go see. Steps 1, 2, and 3. Steps 1, 2, and 3. Okay? Oh wait, that shouldn't be a B. That should be a B. Yeah. It's back on my desk.
Can you go back where you are?
Just for 1 second? Okay. Just for 1 second. Steps 1, 2, and 3. Find the first few terms, identify the pattern, plug into a formula. Alright, here we go. Here we go. Okay. We're going to start gonna make a little table just to help us keep track of things. But you don't necessarily have to. I'm just showing you what I'm doing. I'm gonna say for the first term, second term, third term, if we can't see a pattern, we might keep going. Then I'm gonna plug it into the a sub n. Now, guys, if I was to plug in 1, I would plug in 1 to the n spot and to the n spot. So I'd have negative 1 plus 1. What's a sub 1? The first term, and then when I plug in and simplify, what do I get, Angel?
Can I move to Rob C one so I can see the problem?
Because you literally can't see it then? Okay, let's go to my box. Take all your stuff with you? Is that cool? Alright, Vivek, what do you see? Negative 1 plus 1, what's our first term? Oh, sorry. Right here, do you see where I am?
Oh.
There you go. So we plugged in 1 to the formula, plugged it into the n spot and the n spot. What do we get? Negative 1 plus 1 is? Got it. If we find the second term, Jordan, negative 2 plus 1. What's our second term? Got it. Third term, Jay, what do you see when we plug in 3 to the formula? Got it. Hey guys, is that enough to see a pattern?
I think so.
What would the fourth term be? Got it. So we find the pattern. Why are we laughing? There's nothing funny about finding a pattern. We find the pattern.
Math is funny.
You do you. You look, you laugh, you shake your head. Exactly. See, I go, where's the board? There. Keep your eyes. Turn your head. Ready? There you go. Turn your head. There you go. Keep it there. Okay. Second thing. First step, find the first few terms. Second step, identify the pattern. So every time you are adding what? Negative 1. So then we take the English and we say, okay, it's time to make a formula. Take the English and put it into math. The nth term, we always start with a sub n. How am I going to show adding negative 1 to the previous term?
So that equals a sub n minus 1 minus sub n minus 4.
You guys able to take the English and make it into math? To find a term, take the previous term minus 1. Or plus a negative 1. So then let's try one more example right over here. Let's stop all the singing and humming. I know you guys, it's really hard to focus. So let's try to be quiet. It usually works better when we're quiet and not looking at other people. How am I going to start the second problem? Do you want me to zoom in just a little bit?
Yes.
How do I start the second problem? Make a chart and plug in first term, second term, third term. We'll see if we can find a pattern by then. Is that okay? Now this one might be a little harder to plug in too.
It gave us A, right? A is 4.
They just gave us a formula. This is actually called an explicit formula where you just plug in n. You don't have to do an a sub n minus 1. It's called an explicit formula. If we plug in for n equals 1, well, we plug in there, we have to plug in here, right? What would be negative 2.5 times 4 to the 1 minus 1? Well, wait, what is 1 minus 1?
0.
0. What's anything to the 0 power?
1.
1. Now, some of you might need to show more work than others, but when we go to plug in, we end up with just negative 2.5. Struggle. So we have negative 2.5. Go ahead. Now, to find the second term, Angel, go ahead, bud. What's up?
No, I have a question. Why did you stop at 3, but you
Oh. Because we're going to see if we can find a pattern without doing too many terms. If we can find a pattern, then we'll go to the fourth one. Does that make sense? Negative 2.5. Negative 2.5. If I can make that point a little darker. If we were to go find a sub 2, and if you guys notice, I'm kind of running out of room. So let me come over here. A sub 2. We would get negative 2.5 times 4 to the 2 minus 1. What's 2 minus 1? 1, right? So then, I can say negative 2.5 times 4 guys with fractions? 8 we good? It might be a little easier to see this as instead -5 halves times 4. That might be a little easier. That's a 1, that's a 2. We end up with actually -10. The math got a little messy up there, but we'll go ahead and plug it in down here. -10.
Wait a minute.
Oh, no, 'cause you have the multiply.
That ain't right.
It's 5/2 times 4/1. 5/2 times 4/1. We'll do one more, see if we can hopefully find a pattern now, because this math is getting gross.
That's getting icky.
So now we have -2.5. Yeah, it'd be 4 squared now, right?
Yeah.
So that'd be -2.5 times 16. Go ahead and hand it to me, Jordan. Thank you. Thank you.
You want me to throw it away?
Okay, we end up, oh, thank you. 4 squared ends up being 16, right? I'm not going to do all the math right this second, but it ends up being -5 halves times 16, which would end up being -40.
Yes, I got it.
Now this is kind of crazy.
Huh?
Can you guys
Wait.
tell? I know it's weird, right?
How come it did that?
Can you tell what's going on? Now is this jump easy to see? But this one's a little bit easier. Doesn't it look like times 4?
Oh, I thought that was 25, not 2.5.
Oh, it's 2.5.
That's why it looked really crazy.
So can anybody do mental math and tell what times 4 would end up being?
Ow!
Good, good, good.
Yeah.
So question, guys, that was step number 1. Alright, stay an extra minute. Step number 2. Stay an extra 2 minutes.
You guys, stop talking.
Stay an extra 3 minutes.
Yeah. Oh my.
Stay an extra 4. Barry, you shouldn't have talked. Angel shouldn't have laughed. 5. If we can be good, that might decrease, but right now, we will. So step number 2. The pattern is multiplying by then number 3, we can say the English to math. To get the nth term, how can we find it? You may talk as long as you're participating. To find the nth term, go ahead, Kiwi.
No, it's 4 and 8 sub n minus 1.
Is that valid and correct? I would say yes, but some of you are saying, can't we write it another way?
No, it's a sub n equals -4.
No, wait, pause. Look, don't they technically mean? Oh, only productive talking. Other talking is not allowed right now, else we're going to 6 minutes. Okay, then stop. Look at the 2 up at the board. Do both of them mean multiply the previous term by 4? Yeah. Now, which one is the least confusing as far as how it's written? What do you guys think?
The first one.
Probably the first one. I would say is the least confusing, but technically either one I would say is totally fine and totally correct. Okay? Now, with that, let me take off a minute. Let's go to 4. You guys are being pretty good. You got that answer right. What are the steps that we are taking one more time for taking a recursive rule, or I should say taking an explicit rule and making it recursive? Number 1, you got to find the first few terms, and if you guys want to write yourselves a note, we will say using or with a table, right?
Yeah.
Step number 2, identify the pattern. Long story short, we're trying to figure out in words what's going on. And then step number 3, a recursive formula. We always start with a sub n, and we need to go ahead and somehow plug in the pattern that we are performing. Somehow do the pattern to the a sub n minus 1, which could be a sub n minus 1 plus or minus a number. It could be a sub n plus 1 times or divided or multiplied by 1 over a number. But that is how we finish off the steps. Now, I'm going to go ahead and go back to the homework that I had up over here. Now, let's check out. Don't be stressing. Don't be stressing. Let's go see these problems. Okay? I have these problems. Let's go check out what kinds of things we're going to be doing tonight. Remember 16 through 18, which is right over here. The directions are going to be, okay? Write a recursive rule for the sequence, which means find a pattern. And you guys actually had 13 through 15. I just gave you a few extra ones to practice some more. Find a pattern and write a rule from what you can see and you're thinking of with the English. Okay? Now, I didn't give you 19 and 20. I did give you, though, number 21. What's weird about number 21?
It looks like a figure 21.
Yeah, well, hold on. Read the words. Write a recursive rule for the number of bacteria cells. What's going on? You start with one bacteria cell in 2 hours, or in 1 hour, from 1 to 2. It's doubled. Then it doubles again, doubles again. Wait, hold on. How can we make this into a sequence? How many cells are there at 1 hour? 1. How many cells are there at 2 hours?
2.
2. How about at 3 hours?
4.
4. How about at 4 hours?
8.
Oh, guys, we don't even have to worry about the cells and how weird they look, right? We just get to go ahead and say, hey, this is what type of sequence?
1, 2, 4, 6.
Geometric. What's my common ratio? What do I multiply by? 2 times 2. And could I write a recursive rule about how the nth term is the previous term times 2? Or has Kaylee brought up maybe 2 times the previous term is a better way of doing it? Jake, go ahead. Nope. Got away. Hang in there, buddy. Obviously. You guys have been paying attention, so I'll knock another minute off. We're down to only 3. It's better than 5. And if we can focus for a little bit longer, then we might be able to go down to 2. Now, we've done all the homework, or at least looked at it, up to number 29 to 32. Let's go check out what's going on there. Do these directions, wait, do they look familiar? Yeah. Write a recursive rule for the explicit. What are you going to be doing on these ones, guys? You're going to start by step number 1. Wait, doesn't it look like these?
Find your terms.
Yeah. Step 1, find the terms. Take off a half minute for that. Step 2, what are we going to do? Find the pattern. I'll take off a half minute for that. Step number 3, what are we going to do?
Plug in the recursive formula.
Ah, Rob, look at you go. Take off a half minute. You guys only have 40 seconds left.
Wow.
What's the end of homework going to look like?
A n equals.
Oh, I was looking at the last few problems. 35 to 38. Oh, guys, look. It's the English like we did in class. Woo! Take the English, and what are we going to do? Plug it in and write a rule. Now, wait. That's a good question, Angel. Wait. Guys, look at the directions. Look at the directions. I don't want to have to add time. Do you remember how I said I would not make you find explicit rules?
Yes.
So when you get to the last homework problems, the ones with words, you have to do everything but the explicit rule. Ignore that part, okay? Alright, with that, you guys can do that. I'll see you later. Do everything but the explicit. Everything else.
I think he said. Yeah, he did.
Explicit is like this. Explicit is this. I say you don't have to find that one. Find these. Hold on, Felix.
I did all the way up to 30, part of 35.
That's all you guys do. Over here. Tell me something as to why you got it.
Hey!
15 months.
I left my
Jordan, that's our whole big
James Jordan.
Nobody call me Jordan.
Okay, hold on. These ones, you're going to make a chart and you're going to make something with the direction. I said do one more thing. I say just do this. Nothing more. All of these. These are I would use my
You go like
and then you weren't showing your words. I think you